Hey, so today we'll cover the last section in ODEs, which is boundary value problems. Okay, so let's see what boundary value problems are. So boundary value. So the abbreviation for boundary value problem is BVP. A BVP problem has at least one condition that is not defined at the initial time, or if you assume that it's x is your time might not be the right way, but let's say that it's x initial state. So that is at okay. So if something is starting at x equals x0, that would be an initial value problem. So you're given, let's say, if you're trying to, if there's a car and then you're given the position of the car at time t equals 0 and velocity of the car at t equals 0, that would be an initial value problem. Those are the problems we've done so far. But for boundary value problems, you will not have all the conditions defined at initial time or initial state. So an example of this would be if you were, for example, given dy dx square is f of xy, and we're given that x equals x0 is y0. So that's an initial condition. But then you could also be given some condition at some other time. This is the boundary value. Or you could have a case where instead of defining values at two different values of y at two different x values, you could be given something like this: f of x comma y dy dx. Sorry, let's say that y at x equals x0 is given, but then the second condition is on the rate of change of y. Okay. One example which just comes to my mind is that when you have a simply supported beam, so there's a load, and then this is x, this is y. Usually you will have a differential equation. It's usually EI t square y dx square equals m of x something you need to find, but then you are given, so this is the problem. So that's the governing equation of a cantilever beam. If you can find m of x by basically taking moments and so on, that's not the point. The point is, how do you solve this? Well, if this is x equals 0, x equals L, then you're given x equals 0 is 0, but x equals L is 0, right? The displacement at 0 and displacement at L is 0. This would be, this in fact is the boundary value. Boundary value problems are much harder to solve than initial value problems because you can only integrate the differential equation. So given an initial value, you integrate, you get something at the end of whatever time interval or interval for x. And then based on what you guess, you'll either hit this boundary that you'll get this value or you'll not get this value. So you have to keep guessing the initial value such that you get the right value. So that's pretty much how boundary value problems are solved. So that's next part. I will show you how to solve boundary value problems. They are usually much easier to solve using a program, but we can solve some specific special problems by hand, and we'll only do those special problems by hand. So I'll show you two methods to solve boundary value problem. Number one is called the shooting method. The second one is called the finite difference method.